and welcome viewers. In today's lecture, we are going to study the basic concepts of PAL and the implementation of PAL using an example. The PAL device is similar to PLA. However, in PAL, only AND gates are programmable, whereas the OR gates are fixed in PAL. This makes the device more flexible, easier to program, and cost-friendly than PLA. They are used to implement logic functions in digital circuits. The figure represented is the general structure of a PAL device. It has n inputs feeding to buffers or inverters. These inverters are connected to the AND gates through programmable P-links. The output generated from AND array are fed to the OR array, which has fixed connections. Not all outputs of AND array are connected to the OR array. The M outputs from the OR array is generated. The circuit diagram of PAL shows the 4 inputs, 8 AND gates and 3 OR gates correspondingly. It's noted that while all the inverters are connected to AND gates through links, the output functions F1 is connected to 3 AND gates, F2 is connected to 3 AND gates, while F3 is connected to 2 AND gates, thus generating 8 product terms. Here, only 1 or 2 OR gates may have 3 product terms, whereas the rest of the gates will have 2 product terms only. Implementation of PAL using an example. Now let us consider the following example. The truth table of the above example is shown as. The K-map of the following example is given as. The Boolean expressions are F1 A B C D is equal to B C naught D naught plus A naught C naught D plus B C D. F2 A B C D is equal to A naught B naught C naught plus A naught B D plus B naught C D naught. F3 A B C D is equal to A naught B plus B C D. This is implemented using the circuit diagram. Here we see there are 4 inputs, 8 output variables and 3 output functions. Inputs A, B, C, D and their corresponding complements are linked using AND as well as OR gates, forming their corresponding Boolean expressions of the output functions. For case 1, for F1 A, B, C, D is equal to B, C naught, D naught plus A naught, C naught, D plus B, C, D. Here B and C naught and D naught or A naught and C naught and D or B and C and D generates output function F1. Case 2. For F2 A, B, C, D is equal to A naught, B naught, C naught plus A naught, B, D plus B naught, C, D naught. Here A naught and B naught and C naught or A naught and B and D or B naught and C and D naught generates output functions F2. Case 3. For F3 A, B, C, D is equal to A naught B plus B, C, D. Here A naught and B or B and C and D generates output function F3. In today's lecture, we have learned Introduction to PAL, implementation of an example using PAL. With this, we have come to an end of this lecture. We will meet again in the next lecture. Till then, keep on learning and practicing. Thank you and goodbye.